Netlabs Hub. Welcome to Netlabs Hub. Today I'm going to teach you network access. This is a subtopic day 4 under CCNA 1, Introduction to Computer Networks. As you can see, this is my course roadmap that I'm going to use. So let me be back to my lecture notes. This is chapter 4, network access. What do you think about network access? I'm going to explore how users access the network, how the network access layer entails, how it is. So this is it. As you can see, let me zoom a bit. So these are the objectives that I'm going to measure on. So in the network access, we've got different protocols that serve at the network access. It's data link used to put frames on the network, and also the physical layer. These are the first two layers of the OSI model. So these are the objective of the course. You can see the physical layer. I'm going to talk about the protocols that serve under physical layer, identify the connectivity options under that particular layer, describe the basic principles of that particular layer. Then the network media, I'm going to go deeper what a network media is. Network media, these are just the channel or the path that the packets take while traversing the network, and it might be fiber or UTP. So you're gonna learn more about that. So next section, I'm going to dig deeper about the data link layer, the layers that are composed in the data link, what they do, what are their features, and what are their implications on the network. So the next, I'm going to talk about media access control, how we can control media, that is the data and video on that particular medium. So we'll start with the physical layer protocols. So types of connections. You can see on this image here, this is a home router, embedded wireless antenna. It has an internal wireless antenna which serves or which provides the wireless or Wi-Fi to the users. Also, you can see this router is created in a way that it can provide direct connection to computer, so it can serve also as the switch, because it has multiple ports here. You can see it's serving as an Ethernet switch. So this is the one port, wide area network port here, that is bringing the service into this. You can see, and the computer here, this is a user accessing the service through the Ethernet switch. So this is one of the physical layer connection. So before the network communication can occur, a physical connection to a local network must be established. So as this one, you can see, this is a physical connection. This is an Ethernet cable or a UTP cable that has been used to link the computer to the router. So after the physical connection, which can be wired or wireless, that is when now the network can be accessed. Next, for you to be able to access the network, we've got what we call NIC, Network Interface Card. Network Interface Card connects a device to the network. So it is used mainly for wired connection, especially in local area network where you'll find the NIC. But if it applies for Wi-Fi, then that goes for VLAN, that is the wireless local area network. It uses the wireless network interface cards. So for this case, as you can see, this range extender here, it is having wireless network interface card that is providing the network connection to this particular wireless nodes on this particular wireless local area network. So this is it. At the introduction of this particular chapter, I talked about the OSI model. As you can see, these are the models of the layers of the OSI model. OSI is the Open System Interconnection model, used to act as a reference layer during communication on the network, and it is one of the model that is under that manages the standards. You can see, so in the network access, the layers of consideration on that OSI model is the physical layer and the data link layer. This one, data link and physical layer. So this is the first layer, second, third, fourth. Application is the seventh. So once the frames are at the data link, they are placed on the media, and the media lies on the physical layer. So the media converts the frames into signals, and signals travels through binary, that's 0 and 1s, up to the recipient's physical layer for reconversion. So physical layer, it provides means to transport the bits that make up a data link layer frames across the network media. Access accepts a complete frame from the data link. This is what I have just explained here. Encoding is also done, as you can see. So just as a quick guide on this, when information is at the application layer, it is called data. When it comes to presentation session, it is still data, but the moment is at transport layer, we call it segment or a segment. Then at the network layer is called a packet. Then the data link is called a trailer or a frame. Once it reaches at physical layer, we call it bits. So that's what you should know. Then physical layer media. What are these? Media is the path taken by data or packets within the network, moving from one location to the other. The tunnel or the channel that is used, that is media. So we've got three basic forms of network media. We've got the electrical signals, light pulse, then microwave signal. So if at all I can just start with the electrical signal, you can see how the signals move from one node to the other, or from one point to the other. This is mostly copper cable. And when copper cable, I mean that we might have the Ethernet cable mostly are used here. The UTP, the unshielded two-state pair, the shielded ones, the UTP, STP are used here. So that is the example one of physical layer media, things that you can touch. So we've got second form, we've got light pulse, so that information or data moves in terms of light pulses. So the media that is responsible in this category is the fiber optic. So you find that there are also different types of fiber optics and the situations under which they are used. So we'll discuss about that later. Then we've got microwave signals. This is mostly wireless. So when asked about the forms of media that exist, you talk about the electrical signal, the light pulse, or the microwave, or generally the copper, fiber optic, then wireless. So the purpose of the physical layer, what is the general purpose of the physical layer according to the standardization bodies? You can see we've got International Organization for Standardization, that is ISO. That is the body that came up with the OSI, Open System Interconnection Model. So initially, products from one vendor couldn't communicate with other products from the other vendors. So the ISO, that is the International Organization for Standardization, came up with the model to ensure that all manufacturers dealing with that particular brand of the product have to follow certain standards for them to come up with something that is compatible. That's why you can find a device from HP comfortably communicating with a device from Toshiba or Apple that way. So there is a pattern that the manufacturers are following, starting from the electrical base up to the architecture and all that. There are some standards that they are obeyed internationally. So we've got these bodies. Sometimes they can ask you in CCNA which one of the following bodies maybe deals with a certain sector. So you must be aware of this. So we've got Telecommunication Industry Association, that is TIA or EIA. This one deals with telecommunications or technologies revolving that. We've got International Telecommunication Union. So the two, they are there. We've got American National Standards Institute. This one deals with the encoding and how numbers are encoded. Institute of Electrical and Electronics. This one deals with the electrical and electronics as this is concerned. So you can find that majority of these particular bodies play a major role at physical layer. You can see here, the physical layer standards are implemented in hardware and are governed by many organizations, including this. You see? So you can be just simply asked to highlight, maybe to state the organization or the standard bodies that are responsible for managing the hardware compatibility in physical layer. So you must be aware of that. So identifying network devices and cabling. Maybe I can just start Cisco packet tracer at the moment so that I can show you how to identify network media. What are these? Because of this. So we've got physical functions, we've got encoding, signaling. So it determines how signals shall move. It also determines how the encoding, which best way of encoding will the bits go through. So that is the function of the physical layer. You should be aware of that. Also, the bandwidth management, it deals with that. So like the physical layer has that capacity to determine the bandwidth that a particular medium can hold or can execute at a particular time. So capacity of a medium to carry data, that is a bandwidth. We've got throughput. You should understand all those factors. So digital bandwidth measures the amount of data that can flow from one place to another in a given amount of time. For example, the sender cannot receive data at 1000 megabits per second, then the receiver is receiving at 100 megabits per second. That one cannot happen. So both ends should negotiate to find a better amount of data that they are going to comfortably transmit, and that is where the physical layer comes in with the media access control. All those stuffs are there. So these are some of the units of bandwidth that you should understand, because this one will serve as a more of interest when it comes to spanning tree calculation of the root ports or root cost, etc. So we've got throughput, the measure of the transfer of bits across the media over a given period of time. This is the measure, while the bandwidth is the capacity that the media can carry. You can see. So this is the throughput, the download speed, the upload speed. So what you always see that the internet speed, so that's the throughput. You should differentiate that. And also usually there's not much specified bandwidth. Sometimes you can be told by a provider that he's connecting you with 100 Mbps, but when you do a speed test, you find that you are having maybe 70 download speed, then upload you are having 80. So we've got factors that affect or cause those fluctuations. For example, the amount of traffic that is flowing, the type of traffic. You can see data is a little bit is a little bit manageable compared to voice or video, which is bandwidth hungry. So the type of traffic that is flowing determines the amount of throughput or amount of bandwidth that is consumed. So the amount of traffic, the type of the traffic, the latency created by the network devices. For example, the quality or the number of devices that you are using on your network also have an impact when it comes to throughput determination. So these are the things you should consider. Do not maybe question a lot about the provider that, oh, my internet is not worth what you said. There are factors that are causing that. Latency, the type of traffic, the amount of traffic, the quality and the number of also devices. You see? We've got good put. Good put is the throughput minus traffic overhead for establishing sessions. So you may find that good put is that they say that it's the throughput minus traffic overhead for establishing sessions. So for example, you will take the throughput here, then minus the overhead, the alternative issues that are causing the variations there. So we've got types of media. The figure shows different types of interfaces and ports available in 1900 series router. When you see 1941, this is just the number for that router, but its series, it is lying in the 1900 series. So you can see these are the interfaces. You can see this device. There are how many ports? 1, 2, 3, 4, 5, 6, 7. So these are the fast Ethernet switch. They are operating at 100 Mbps, that's megabits per second. So these are the special ports, the gigabit, you can see. These are the management ports, these two. Then this is the DCL, the service subscriber interface. And this one, this is the USB. You can connect your console through USB-based console. And this is the gigabit in the interface. So this is a 1941 router, which can serve as a switch at the same time as a router, because you can see here, depending on the configuration. So let's go deeper on the network media. When we start with copper cabling, what are these types of cables that are under copper? So these are the things that you should understand. So characteristics of copper media. What are these factors that affect copper? When I mean copper, the UTP cables are under this category. So we've got attenuation. These are factors that affect copper media. The longer the signal travels, the more it deteriorates. It means like signals tends to weaken as distance gets to increase. So these are the factors. That's why UTP is limited to less than 100 meters, beyond which this attenuation will kick in. The signal will deteriorate and it will weaken. All copper media must follow a strict distance limitation, that is of 100 meters. So for you to be safe, ensure that even you don't cross 100 or you don't reach 100, the better. So copper media are also affected by electromagnetic interference, EMI, or radio frequency interference, RFI. This distorts and corrupts the data signals being carried by the copper. We've got crosstalk. Crosstalk, this is the disturbance or the noise caused by the electric or magnetic fields of a signal on one wire to the adjacent. So factors affecting copper media, we've got attenuation, we've got electrical magnetic interference, we've got crosstalk. So these are the things that you should put into consideration. and by the picture you can see how it is. So you see these are normal digital signal. When the distance is longer, this is how the signal will behave. This is this is a digital signal with the interference, what the computer reads, you see. And you see here is a red. You will miss some signals. So there are three main types of copper media. We've got the unshielded twisted pair, UTP. Unshielded twisted pair. This kind of cables, they are not shielded. As you can see, this is the normal Ethernet cable, the UTP that we use in the local area network. We've got shielded twisted pair. This is shielded. You can see this aluminum foil here. It is protecting the 4 inner core. So this is mostly used in the base stations, creating sectors on the base station in telecommunication setup. If you happen to have been in that area, you can know more about it, or you know what I'm talking about. This is LAN. This is also can be used in LAN depending on the technicality of the person who is crimping it, but mostly people find it rough dealing with this cable and like this. So we've got this one. This is the coaxial, mostly used to be applied on the providing as TV antennas. And this is also, it's used on the devices like it is used to provide, to connect devices like the IoT, all those things. So these are the copper media that you should understand. There are three categories. We've got coaxial, the UTP, and STP. The shielded ones have the aluminum foil. This is just to protect the inner cores. We've got unshielded, the one that just has a plastic foil, a plastic cover, and then. So we start with unshielded twisted pair. Is the most common. You see, it's the most common, meaning it is applied or used in the LAN, that's local area network. It is terminated with RJ45 connectors. It is used for interconnecting network host with network devices such as switches. So majority of it is used in the setting up the LAN. You can see these are the twisted pair. So the wires are crossing each other. So to counter the crosstalk, you can see here. In the exam, they can draw this and they tell you, or they ask you, what is the essence of crossing this wire on each other? That one to counter the crosstalk, the interference between those particular magnetic waves caused. So outer jacket just protects the copper wire from physical damage. Then twisted pair protects the signal from interference, that is crosstalk. And the color-coded plastic isolates the wires from each other, you can see. So that is it. When we come to shielded pair, it's a bit complex. It has more layers compared to that. It provides a better noise protection than the unshielded twisted pair. STP cable is significantly more expensive and difficult to install. You find that majority of Cat 6 and Cat 6 and Cat 5, they are in this category. So we've got the general jacket that protects the inner parts. We've got the braided foil or shield, you can see here. Then after there, we've got the foil shields, then twisted pair. So it also uses RJ45. So the difference between UTP and STP is that the kind of shielding and the cost also. STP tends to be expensive more, unlike UTP. So this is coaxial. Coax consists of a copper conductor used to transmit the electric signals. You can see copper conductor. This is the copper conductor. The innermost core. A layer of flexible plastic insulation surrounding the copper. So this is just an insulator. The insulating material is surrounded with a woven copper braid, a metallic foil that acts as a second wire in circuit and as a shield for the inner conductor. So you can see this is BNC, N-type, then F-type. So like you see coax cable, it has different connectors, and these different connectors have different functionalities in application. So UTP cables has essentially replaced coaxial cable in modern Ethernet installation, but it is used in wireless installation. So majority of the IoT, you will find this format and cable internet installation. So copper media safety. Copper media are susceptible to fire and electrical hazards. So it is advisable that you should not just leave your copper wires outside. If need be, you see the kind of crimping that has been done here. There are these particular jackets that have protected the data. You can find that the separation of the data and electrical power. So that is one of the features that brings safety among copper media. Then we've got the grounded and the protected. So like even though there is shock, some of the electric charges are grounded, so there is no impact on the humans. So we've got properties of UTP cable. What are the properties? It consists of 4 pairs of color-coded copper. Small size can be advantageous during installation. Does not use shielding to counter the effects of EMI. So cancellation, when two wires in an electrical circuit are placed close to each other, the magnetic fields tend to weaken the signal, as you can see. So these are the standards. We've got category 3. Sometimes it is called Cat 3. Cat means a category. Then we've got Cat 5, then Cat 6. So majority of STP starts Cat 6 and above, you can see. So these are gigabit transport data or at a speed or a bandwidth of 1000 megabits per second. So Cat 3 mostly used for voice communication, used for phone lines, which is rare. 5 and 5E are used for data transmission. Majority of the LAN cables that we are using lie between 5 and 5E. So supports 100 megabits to 1000, but it is not recommended. Cat 5E supports 1000. So category 5E, it's an extension of category 5. Huh? That's what you should master here. Category 6, it is used for data transmission. An added separator is between each wire, as you can see. It goes up to 10 gig. So majority of this you can find that. That's why I told you that majority of Cat 6 cables are used in base stations. That's where base station setting up the sector antennas. So UTP connectors, we've got the RJ45 plugs here, you can see. Then RJ for UTP sockets. So majority of these are used on the walls to terminate the LAN cables. This is poor crimping. The best crimping should be this, but this one will affect you in the future. So you should always crimp your cables at least to marry this particular picture here. Types of UTP cables. For example, we've got T568A, then T568B. When I say T568A, there is a color coding that marries that standard. Then T568B, there is a color coding that marries this standard. So we've got T568B. So if you do T568B one side, T568B the other side, that is a straight through. When you do T568A on one side, T568A on the other side, that is a straight through still. But when you do one side T568A, then the other side is you crimp it to T568B, that's a crossover. So those are the things that you should master here. And the color coding is very key. For example, T568B, you start with white orange, then orange, white green, then blue, then green, after white green, then white brown, then brown. So how to test the UTP cables? We've got what we call the cable tester. So it will test the, like, basing on the length of the wire, the signal loss due to attenuation, the crosstalk. Those are the things what a cable tester will do. I told you that on the media. So this is Cisco packet tracer. Media is at this section, connections, you can see. When you choose this one, it will determine which cable suits the connection. So this is the console used to access newly acquired device. This is copper straight through. If crimped T568A both ends or T568B both ends, that is copper straight through. We've got crossover, meaning one end is A, the other end is B. We've got fiber this way. We've got that. That's the phone. Then that is coaxial. So then these are the IoT. So that is about the cables that I had promised earlier to show you. So building an Ethernet crossover, you see. So meaning piece A is going to have T568A, then the other end is going to have T568B. So that is a crossover cable. And you can see this NIC will have this address, then this NIC for this laptop is going to have this. So these are something that we can do in Cisco packet tracer. Connecting to computers, it's not a big deal. We can still connect. Just come here, pick one PC there, then pick a cable. We can pick this one. You can see the moment I connect, I have used this one, automatically choose the connection type. The moment I have used that one, it has automatically determined the best suitable media between these two PC. And that is the crossover here. So that's what they are doing. That is the example here, you can see. So properties of fiber, optic cabling. So fiber, generally, just to summarize, fiber transmits data over longer distance compared to UTP or copper cables at a higher bandwidth. It is mostly preferred if speed is a priority. Transmits signals with less attenuation. So in fiber optic, there is no EMI or RFI. There is no electromagnetic interference or frequency interference. So it is used to interconnect the networks. So majority of these fiber cables are used at least to link multiple networks. So because to minimize on downtime, it is flexible but extremely thin, transparent, generally expensive. So those are some of the features that you should understand when it comes to fiber. You see the way fiber is modeled. There is jacket, there is strengthening material, there is buffer, cladding, core. So these are the functions of all these things. The jacket protects the fiber against moisture and other constraints. Strengthening material surrounds the buffer, prevents the fiber cable from being stretched. The buffer is used to shield the core. Cladding tends to do what? To mirror by reflecting light back into the core to ensure that at least light is concentrated at the core. So types of fiber media, we've got single mode and multi-mode. Single mode produces single straight path for light. Then multi-mode allows multiple paths for light. Then there are other factors or properties. So single mode, it has a small core. It is less dispersion, suited for longer distance. Uses lasers as light source, commonly used with campus backbone for distance or of several thousand meters. So multimode is strictly limited to maybe 500 meters. So you see it has a larger core, allows greater dispersion and therefore loss of signal, suited for longer distance application but shorter than single mode. You see, it uses light emitting diodes as light source. So those are some of the properties that you should distinguish between the single mode and the multi-mode. The single mode produces single straight path for light. Then the multi-mode produces multiple paths for light. Fiber optic connectors, we've got these connectors, we've got ST connectors, we've got SC connectors, LC connectors, then duplex mode connectors. When are they used? What are they? So if we start with ST, that is straight tip, one for the first connector type used, lock securely with the twist on, twist off. Then subscriber connector, this is mostly used by providers terminating the fiber to the switches. They use SSC, referred to as square or standard connector, used to push-pull mechanism to ensure positive insertion. We've got loosened connector, smaller version of SC, still part of subscriber connectors, then duplex multimode. So this is used in the local area network, ST connectors. Duplex mode, they are used majority of SFP, that is swappable pluggable modules. We've got fiber optic connectors, you can see. So these are the cables that goes with this, you can see. So if you choose the connector, it should marry the right cable to be used, or else it won't work. So testing fiber, we've got ways of using instruments used to test fiber. We've got the optical time domain reflectometer, that is the OTDR. It can be used to test each fiber optic cable segment. Terminating and splicing fiber optic requires specific training. That's why fiber is expensive, because the expert or the specialty in that area is costly. So 3 common types of fiber optic termination and splicing errors are misalignment, end gap, then end finish. So misalignment, the fiber optic media are not precisely aligned to one another when joined. And that one at least increases the, what we call the loss percentage. The end gap, the media does not completely touch at the splice or connection. Then the end finish, the media ends are not well polished, you see. If they have some like fine dust, it will cause the flow of light. So fiber versus copper. Fiber is the best when compared to copper in terms of the bandwidth that is carried, the distance, then the immunity to EMI and RFI, immunity to electrical hazards, also media and connector costs. It's a little bit lower compared to like the media and connector for UTP is lower, but for the fiber is expensive. But generally fiber stands out, unlike UTP, in terms of distance it can go, the bandwidth it can support, the immunity to EMI and RFI, and also immunity to electrical hazards. Those are the factors that you should understand. They will give you a scenario during an exam that maybe an organization wants to connect to its adjacent network or to its branch network. What is the, maybe that is maybe like 300 kilometers or 300 maybe meters away. What is the suitable alternative for this? So think in line with this. They might not bring you direct concepts as I am explaining here. So properties of wireless media, you can see coverage area, interference, the security, and shared medium. These are the properties of the wireless media. So the coverage area, construction materials, these are the just obstruction the area they cover. Interference disturbed by such common devices such as fluorescent lights, microwave ovens, and other communications. Security devices and users not authorized for access to the network can gain access to the transmission because it's just open, you see. Types of wireless media, we've got the Wi-Fi, Bluetooth, and WiMAX. Wi-Fi, that is standard IEEE 802.11. Uses carrier-sensitive multiple access or carrier-sensitive collision avoidance. Wireless NIC must wait till the channel is clear. Bluetooth, that is 802.15. It supports wireless personal area network. Uses device pairing process for a distance 1 to 100 meters. Then WiMAX, worldwide interoperability for microwave. So this is used for broadband access. Then wireless LAN. When we come to wireless LAN, so here we are just talking about the wireless routers, then the wireless access point that concentrates the wireless signal around users, and also the wireless NIC. It has wireless NIC adapters that provide the wireless NIC that provides the communication capability to users that are around the coverage area. Then the connectivity of wireless and wireless LAN, you can see. So this is the wireless home router. It's providing the Wi-Fi to this wireless home PC, the family PC, and the home printer. And this is the LAN. You can see the cables are used here, you see. So this is what we can do in the Cisco packet tracer. Data link protocols. So data link protocols, we've got two main protocols or sub layers in this main layer that I'm going to discuss. So layer 2, this is the header for data link layer. We've got destination NIC, that is the MAC address, then the source MAC address. So the destination NIC and the source NIC, that one marks to be layer 2 header. Then layer 3 header, that is the source IP address and the destination IP address. You should be distinctive when it comes to such. So data link sublayers, we've got the logical link control sublayer, then the MAC media access control. So this one manages the media, how the data is placed on the media. It is the role of the media access control. Then how the data will flow or how the frames will be reconverted to the packets, it is the role of the logical link layer, logical link control. So you can see it communicates with the upper network layer. It identifies which network layer protocol is being used for the frame, allows multiple layer 3 protocols such as IP version 4 and version 6 to utilize the same network interface. You can see there. So then media access control, it defines the media access processes performed by the hardware. It also provides data link layer addressing. These are the layers of the data link, and these are the functions. As you can see, it communicates with wireless technologies. Media access control. Providing access to media, as you can see here. LAN header, the packet is in the middle, then LAN trailer. So this one will determine how this packet is placed on the LAN, or placed on the network. So data link layer standards, these are the standards that I talked about during the introduction in the previous slides. This is now deals with how we can control access to the media. So there are some of the topologies that are used, the layouts. So media access control is the equivalent to the traffic rules used in the normal environment that regulate the entrance of motor vehicles onto the road. So before a frame is placed on a media, or a media is chosen to at least to a media is chosen to take care of the frame, then the MAC address must be involved. So the absence of any media access control will be the equivalent of vehicles ignoring all the traffic rules, and that one will cause the accident. And in this case, it will cause what we call collision. So physical and logical topologies. Physical topologies refers to the physical connections and identifies how end devices and infrastructure devices such as routers, switches, and wireless access points are interconnected. Just as you can see, this is the data center of the server room. This is the switch, that is the distribution point. Then this is the core. You can see, then this is the access layer. Or in between here, we can say that this is the distribution point or distribution layer, and then this is the core server room, determining what the access layer is in it. So that is the physical topology. Then when we come to the topology is the flow of data. So it refers to the way a network transfers frames or data from one node to the next. The logical signal paths are defined by the data link layer. You can see how the data will flow from maybe this PC to this particular web server. So common physical wireless wide area network topology. We've got point-to-point, permanent link between 2 points, like this case. We've got hub and spoke, a central site interconnects a branch site using a point-to-point. So in this case, it's a hub and spoke. So we've got a central node that interconnects other nodes. So we've got mesh, provides high availability but requires more cables and so expensive, and also it needs more administrative control. So physical point-to-point topology. So this is how, this is node 1, then node 2. The network is in between. Frames are placed on the media by the node at one end and taken through the media by the node at the other end through the network. So LAN topologies. LAN topologies, this is just how the LAN is orchestrated or it is designed. You can design your LAN in a way that in a star way, so that end devices are connected to central intermediate device. Use, for example, a switch. You can place a switch at the center of the room and ensure that all those computers within that room connects to that switch. So that is one kind of a star topology. Then to extended star, we can join 2 switches now, then to connect with those computers. Computer in one sector connect to one switch and the other connect to the other switch. So bus is used in legacy network. Currently, it's not yet used. We've got ring. End systems are connected to their respective neighbor, forming a ring. So you can connect them in this format. This is a ring. So in LAN topologies, we've got these concepts. We've got a half and full duplex. Half duplex is whereby both devices can transmit and receive on the media, but cannot do so simultaneously. It means once the transmission is done, then the receiving, like one device transmits at a time. If device A is transmitting, B cannot transmit. It waits. So once it receives, that's when it can relay the feedback. Used in legacy bus topologies and Ethernet hubs. Wireless LAN also operate in a half duplex depending on the configuration. Full duplex, this is where both devices can transmit and receive on the media at the same time. Data link layer assumes that the media is available for transmission for both nodes at any time or at any given point. So full duplex is the best. We've got media access control methods. You see how control to the media is determined. We've got each node has its own time to use the media. We've got Likert token ring. We've got contention-based access. So contention-based access, we've got carrier sense multiple access with collision detection, then with collision avoidance. You can see here, so that collision avoider uses a method to detect if the media is clear. If it is clear, then it is transmitted. If it is not clear, it waits. We've got the frame. Each frame type has parts. We've got the header, the data, and the trailer. So these are the composition of the frame that you should understand, and here it is. The header consists of the frame start, that is frame delimiter, then the addressing, the source and destination MAC address here, the type, then the control. The data is in between, which might be the packet. Then the trailer. The trailer, its role is just to ensure that it is free frame check sequence FCS, checking the errors if it can happen, or if it has happened, how to control. Then layer 2 address, you can see NIC, these are the MAC address. Then so NIC, this is MAC address. It is at layer 2, that is the data link. Then L3, that is the network. So network, it goes with the IP address. As you can see here, destination NIC, source NIC. This is destination MAC address, then source MAC address. LAN and WAN frames. Layer 2 protocols used for topologies determined by the technology. Data link layer protocols include the Ethernet 802.11, that is the wireless standards, then point-to-point, that is PPP, then HDLC, then frame relay. So these are the data link layer protocols that are used. So thank you so much for this, for having taken your time to follow this particular course, day 4, the network access. So stay tuned at network. Stay tuned for this particular course until the end. And if you feel so much helped as CCNA is concerned, feel free to subscribe. Feel free to subscribe, comment, like, share at Netlabs Hub. And I'm also open for collaboration in any case of maybe you come across something that across this course that you've not maybe gotten clearly. Just leave a comment, then I'll share these particular notes with you, or I'll just create a dedicated time to practice these particular labs with you.